right, hello all. Let's continue and finish up graphing square root functions, finding their domain and range, and talking about transformations. The only new transformation we have discussed is flipping the graph to the left, which is a reflection over the y-axis, okay? So if you see a negative on the inside of the square root on the x, that means it's been reflected over the y-axis, okay? So let's take a look at this. So we know the shift. Basic, when you see x minus or x plus the number, you can just say, oh, take the opposite sign. So I know it's going to move 1 to the right and 3 up, okay? And I know since it's a positive square root in front, it's going to open up. So it's not going to flip down. There's no negative on the inside with the x, so it won't flip to the left. Okay? So now when you go to plot, use that shift, use that shift to the right as 1. Use that 1 as your starting number. So when x is 1, 1 minus 1 is 0. The square root of 0 is 0, plus 3 is 3. So now, you don't want to use numbers and just go up by ones like you do any other graph, like 1, 2, 3, 4. You want to pick numbers that will give you a perfect square when you substitute them in. So notice when you substitute 1 in, you get 0. 0 is a perfect square. The next perfect square is 1. We get 1 by letting x be 2, because 2 minus 1 is 1. Its square root is 1, plus 3 gives me 4. So I'll say that again. You don't want x to be the perfect square. You want, when you substitute in the x value and subtract 1, you get a perfect square. So the next number I'm going to use, I know that I would like this number underneath here to be a 4. The way I would do that is to let x be 5, because 5 minus 1 is 4. The square root of 4 is 2, plus 3 is 5. So I'm going to use those 3 points only, and I'm going to graph. So 1, 3, 2, 4, 5, 5. And I get my top half of a sideways parabola. Sometimes it's easy to graph first before you find the domain because it's very visual. So if you notice here, the domain is 1 to infinity. You can write it either set or interval notation, whichever you prefer. We've been using interval more this year than set. And the range, the lowest y is 3, and it goes up forever. It'll go up slowly, as you can see, but it will continue to go up. It'll never fall. So 3 to infinity. If we look at number 2, we see a negative on the outside. We know that negatives on the outside of a function will flip it down or open down. It's a nice basic x plus or x minus a number. So the shift is 2 to the left and 0 up. So I'm staying at a y value of 0 and just pushing it to the left and opening it down. So again, notice that 2 to the left is my starting x value. Okay? So notice that. The 2 to the left is where I'm going to start my x. When I substitute negative 2 in, plus 2 is 0, the square root is 0. Now, before I just choose any number, I want to choose a number that will now give me 1 underneath here, because 1 is my next perfect square. I started with negative 2, which gave me 0. My next perfect square is 1. I get 1 by letting x be negative 1. Substituting in negative 1 plus 2 is 1. The square root of 1 is 1. Negated is negative 1. So I'll say that again. Substituting in negative 1 plus 2 is 1. The square root of 1 is 1. And then negate it, negative 1. Now I want to substitute in my next perfect square is 4. I want to substitute in an x value that will give me 4 underneath. So that x value is 2. So when I substitute in an x of 2, I get the square root of 4, which is 2, negated, which is negative 2. So here are my values. Negative 2, 0, that's the shift. Negative 1, and 2, negative 2. And as you can see, it opens down. The negative in the front flips it down. And again, it's up to you, either set or interval notation. Domain, again, we read left to right, negative 2 to infinity. Range, down to up, negative infinity to 0. Be careful not to put 2 here because you're seeing that 2 on the x, but you want the y value in the range, so 0. So here, we're going to list all the transformations using our parent graph as the starting graph. So we're starting with y equals radical x and describe all the transformations. Okay? So we know what the 3 does in front. It doesn't change just because the function we're using changes. That 3 is a vertical stretch by a factor of 3. We shift 1 to the right, 4 up. Okay. Number 2, start left, work right. So read it left to right. The negative here, we know what that does. It's a reflection in the x-axis. Please try and use the words x-axis because if you just say reflection, we're now focusing on the x and y-axis. So it's a reflection in the x-axis, a vertical compression by a factor of a 4th. If you notice, this negative here negates the x's. So if you take an x value and you negate it, that's a reflection in the y-axis. And then down 1. So let's look at one more together. And let's see what we're doing here. So this negative is a reflection in the x-axis. Now I need to know how this gets shifted. So we can find the domain, or you can ask yourself, what value for x gets the square root to equal 0? Which goes back to the original function. Okay, so I'll say that again. You can find the domain by setting the radicand greater than or equal to 0, and then solving, and that'll give you your shift. Or you can say, what value for x will give me 0 underneath the radical? And that value is a positive 2. Okay? And we'll see that if we do a little math. Okay? So I'm moving it 2 units right. Notice there's a negative on the x right here. That negative is going to tell me to flip left, which is a reflection in the y-axis. And we're going to go up 3. So that's about as hard as you'll get because it has both reflections and it's a little bit different with the negative on the x. So that's kind of as complicated as it could get. The only other thing I could do would be to put a number in here, which we know is a vertical stretch or compression. So your assignment is attached to, or attached kind of with this video, and it will be due the Wednesday that you return from break, so that if you have any questions on this material, you can come and ask for help. Please don't leave it until the Monday or Tuesday you get back from break, because we're moving on to a different topic, and this is just to help pick up a little bit of pace in the course. Okay, so please feel free to email me and ask me any questions, and I thank you in advance for taking the time to do this, and I hope you are enjoying your break. See you soon.